Hey guys, it's Vince. Today in this video we're going to be discussing CNC plasma systems, and I keep getting questioned daily either from potential clients or past clients who want to transition into plasma cutters, how to go about it, what's involved with it. I'm doing more and more generalized engineering as well as system quotes, so I wanted to just give you guys a breakdown of what you're getting involved with when you get involved in this genre of CNC automation. Okay, without a doubt, it's one of the most profitable areas you can get involved with, because anything dealing with sheet metal that you can cut with, ridiculous amounts of accuracy, there's a lot of money to be made. I mean, most of you see that potential. That being said, it's going to take money to make money. That old cliche is very true. In this instance, plasma systems are some of the highest dollar systems there are because they have many subsystems. Okay, and once again, we'll get into the subsystems. The first component, though, I want to cover is the transmission of your system. I get told every day, numerous times a day, once again, from past clients and potential clients, that they're well able to fabricate their own chassis. They see it as a very basic design, which it is. It doesn't need fancy bearings. The typical transmission that they choose to go with is, and I recommend actually, is a rack and pinion. Okay. Now, once again, why I recommend the rack and pinion is because the chassis has absolutely no load on it. Okay, when it comes to a mill or a router, a ball screw is really going to yield the best precision when it comes to automation. And once again, I want to just confirm that the information I'm providing you guys, I'm taking time out of my day to do this, and I want us all to grow and learn. But I want you to feel that you can validate what I'm saying. And when I say that, I still get every now and then, it doesn't happen very often, but every now and then I'll get someone that'll get me on the phone and say, well, we've never dealt with you before. We still don't know who you are. They have a bad taste in their mouth from a past experience because maybe they were burned. However, all of my videos that I try to do all come with direct representation, not just from me, but from direct links that I'll provide so you guys can do your due diligence and research what I'm saying is accurate. Okay, I've built well over 500 systems, and I'm telling you right now, when I say systems, I mean all systems. I'm not talking about just, civilian type systems. I'm talking full-scale systems. I'm talking everything. So dealing with that, this is a company called Shop Saver. Many of you have heard this company. They do a really good explanation here on explaining different transmissions, ball screw and rack and pinion. And once again, ball screw with linear slides are going to yield the most accuracy on a mill or a router. When it comes to a plasma system where accuracy is not as critical, when I say not as critical, what I'm talking about is your tolerance level. Okay, typically you're probably looking at between 2 to 5 thousandths of an inch with a rack and pinion. Now, if the gear mesh is set correctly and everything is good, you may even get less than that. Okay, most of you are going to be fine with that. Okay, even for functional parts, you'll still be fine with that. The thing to keep in mind is that your tolerance level is going to be based on gear mesh. It's going to be based on motor load. You're going to deal with, all kinds of variables that ball screws just don't have. Okay. Most actual rack and pinions can be set up very simple. They can be set up, once again, with direct motor input, where the motor is just mounted, close where the pinion is to engage the actual rack, and you're basically set to go. I recommend using a piece of shim stock to set your gear mesh. You can go with a thousandth or two to give you proper gear mesh and see where everything is. It should have a very, very slight, few thousandths, maybe even a thousandth or so, depending on how tightly the rack is, mesh, so that everything actually is super, super smooth. I get guys all the time asking me about that. They'll have problems breaking motor shafts. You should never break a motor shaft. What should happen is the gear mesh needs to be set correctly. If it's set correctly, when I say set correctly, guys, the thing about a ball screw setup is it's linear. Okay, so when you actually put that screw on the actual, or I should say the ball nut, excuse me, on the actual unit itself, it's going to be symmetrical from top to bottom as you go across the screw if it's manufactured correctly. With a rack and pinion, you have two separate parts that are joining. Therefore, you have to factor in that there's going to be some inaccuracies when it comes to the actual gear mesh. And when I say that, it may be perfect in one area and not so perfect in another area. It's very common to have your tolerances be off. A lot of that can also be due to how you're mounting the rack on the machine. Therefore, if you're building the machine yourself, keep that in mind. Using a straight level, that might be okay. Make sure you're using one with a very good tolerance. I even recommend a digital angle finder. The digital angle finder will give you a really, really good representation of just how level that rack is. Now, a lot of guys will say, well, you're going way off the deep end as far as accuracy. I'm telling you this once again because I've seen a lot of variances. I've seen variables where a rack can be purchased from a vendor on eBay. The vendor claims it's high quality, it's hardened steel, all this other BS, and then you get it, and the client ends up being, really bent out of shape because what he purchased, when he mounted it and everything, it's just not symmetrical. Do yourself a favor. When you guys are investing in your transmission for your system, do not cut corners. Now, once again, you don't need a ball screw setup. You are not going to need the linear rail setup. But when you're going with a rack and pinion, I highly, highly recommend you look at McMaster-Carr Grainger as your direct supplier for these racks. And the main reason I do is that their quality is, without a doubt, much better off overall as far as the repeatability aspect of purchasing them from numerous clients. They seem to be right where they should be. And once again, it makes sense. They're actually supplying full-scale automation. So you're paying a little more money. You're getting a U.S. company that has U.S. distribution, and they're going to provide you with what you're hoping to get the first time. Will you pay more? Absolutely. Will you get what you pay for? Well, that old cliche is true. So you weigh it on both ends. And I tell guys that all the time. You can go ultra cheap. You can go budget. You go budget, 9 out of 10 times you'll be replacing something. Or, again, you may not be happy with the performance of the machine. So keep that in mind. You're going to go rack and pinion. Once again, I totally agree with that aspect. For automating anything with a plasma system, that's fine. Just make sure you're being reasonable with where you're purchasing from. Vendors do matter, guys. And not just with support, but quality also. I can't emphasize that enough. Biggest question I always get asked, second to that, is, why don't you carry automation parts? Well, the thing about that is I cannot control that at a micro manufacturing level where I feel confident that every unit I'm buying, unless I'm buying and paying retail, that kind of makes no margin there to make the business viable for me. So what I say is I'd rather just see you guys go direct to them, deal with them directly. They're masters of their own craft, and you guys get what you pay for. If more vendors did that, I think you would see the market change very quickly. However, we know that that's not usually the case. They try to make a quick buck, some of them, and when they do that, end users get burned, and that's the absolute truth. So once again, I'm going to put this link for transmissions so you guys can review them right down in the bottom of the description of the video. The next thing I want to discuss with everybody is going to be torch height control, because that is an option as well as a necessity, and I'm going to explain the two. Okay, if you're doing thin sheet metal and you're doing artsy type projects where we're dealing with, lots of just metal art, nothing heavy duty, you're dealing with really, really light gauge metal. The lighter the gauge metal, the more potential for warping you're going to have. Okay, when you're dealing with that kind of heat, you get warpage, the parts then, everything will not look correct. That being said, you got to be really understanding of the budget you're dealing with when you get involved with torch height control. Torch height controllers can start at 300 and can go typically, actually I'm wrong, they probably could start at about 150 and can go easily up to $2,000 depending upon what kind of unit you're buying. Okay, do you want a fully automated system? Do you want AVHC control? Do you want a floating head? All of these different variables come into play. That being said, rather than take my word for it, once again, we go over to Hypertherms website, which Hypertherm makes some of the best plasma cutters in the industry. They're very, very well in depth with their engineering as far as using these systems for automation and CNC robotics. They have a full, and I'm going to put this link down too, explanation of torch height control for plasma cutting. Okay, anybody getting involved with plasma cutting should actually take the time to read these actual blog posts, because I'm telling you now, they are extremely important to get you guys familiar with the basics of what you're dealing with and why plasma cutters are, like I always say, a different animal. A lot of plasma cutting is trial and error. there's not a lot of factual things where everything is definitive. Even milling, I feel, in a lot of ways, is more definitive than plasma cutting, mainly because you're dealing with so many variables. You know, torch height control, like I said, can vary from one guy to the next, can vary from substrate to the next. Could be anything. You know, shop positioning, I know that sounds crazy. One guy's shop may have a more stable power source in certain respects than another guy's shop. Things always come into play. EMI, and I've discussed this numerous times. It's the first topic I always bring up. EMI generated from plasma systems far exceeds that of any CNC robot out there I've seen. Okay? I don't care if you're running three-phase. I don't care. You know, I've seen every kind of setup basically under the sun, and without a doubt, when it comes to plasma cutters, once that torch fires, you guys have a plume of EMI that is generated at just a normal amount. And the issue with that is we don't want penetration into any of our step and direction signals. I don't care if you're running servos. I don't care if you're running closed loop. I've heard, you know, lots of questions. The bottom line is this. When it comes to plasma systems, shielded cable on everything is an absolute must. Absolute must. Distance is also another viable option to actually get involved with as far as using that to give your system more stability. The closer your system is to that table, meaning your controller, your computer, everything, the more penetration you have viable. Just makes logical sense. Keep the chassis away. And when I'm talking about the chassis, I'm talking about the electronics controlling computer. Anything that's sending critical signals that are controlling the system, keep it generally away from the table. I see a lot of guys online that'll mount the box right under the table. You got to use some common sense. I mean, if the torch is firing, and picture that plume that's generated. Once again, it's invisible, but picture that plume similar to what you'd see on like a nuclear bomb where that cloud erupts, that mushroom cloud. It's very similar to that. And when you're putting that kind of sensitive electronics around that general area, whether you're using shielded cable or not, why test everything? Why not just put it, you know, optimal range will be between 6 to 8 feet from the table. Okay, that'll give you plenty of area then to say, okay, I've done everything I can. I'm using shielded cable, you know, go them extra route or go that extra step, excuse me, to make sure that you're doing everything you can to start on the right foot. Because once again, plugging the system in and getting motion in the beginning is one thing. When you plug the system in and you actually go to cut something, that's when you're going to find out if stability is an issue. Okay, it's no different than my guys with mills and routers. They'll typically plug in their system and say, oh man, I've got motion, it's great. But you don't hear the router actually cutting. Till that router's cutting, till the system is fully functional, it is a paperweight. Okay, regardless if it's producing motion, it's a paperweight until you're actually cutting with the system. So always do a simulator with the spindle on. Now, when I say the spindle's on, you don't have to be physically cutting something, although you could. I mean, it will generate more amp usage from the spindle, once it generates resistance. However, use common sense. If you can do a simulator where you're running your spindle, testing everything, I definitely recommend that over just, you know, doing air cuts with the spindle off. This way you'll get a general feel of what is, you know, what is stable and what isn't. Okay, typically if the spindle, I'd say about 85 to 90% of the time, if the spindle is on, you're doing an air cut, you're going to be good. It's the same thing with plasma cutting. Use a piece of substrate you don't care about, test what you're doing, validate system stability, validate control box location. All of those variables play a huge role. Now, once you're setting up your torch height control, as we were discussing, that is hit and miss. You're going to go through a lot of different settings till you find the sweet spot. And I have to say, many of my clients that are using plasma systems, they're never happy. And it's interesting because these guys, they're like scientists when it comes to, okay, well, on this substrate I stay with this, but every now and then I'll adjust from this to this. And, you know, they'll make micro adjustments here and there to make sure that the system produces that repeatability. And on top of that, it will give them more and more refinement over time of that substrate. So their cuts get better, their production times get better. These are all things to think about. You're thinking about slag. So again, speed of the system is more critical because if it's not moving, you're going to generate more slag, makes your parts come out, you know, like crap. You don't want to do that. Are you going to use a water table? If you are, that's great. Keep in mind you're going to be paying more for a water table. Okay, so let's just think in terms of budget now of what we're discussing. A torch height control, once again, it ranges probably on the very, very low end at 150 all the way up to, I've seen them go as high as 2,500. I myself sell units in that range. So what torch height control is best for your system? I get asked about that consistently. It's going to be based on one of two topics. The first is always your budget, okay? The next is going to be your application, okay? Because budget, I don't care what your application is. If your budget doesn't support it, you're never going to be able to afford it. So let's be realistic. If your application is dealing with thicker metals, I've had certain clients get away without using a torch height control. You know, 1/4 inch, and I'd say above, or, you know, anything I'd say below 1/4 inch, because then when you start going below, we start worrying about excess heat production. And that excess heat leads to warping. So keep that in mind. If you're doing, like I said, 1/4 inch and above, a lot of my clients that deal with that kind of thicker material usually get away with not using it. If you plan on doing sheet metal art, it's going to be imperative to get some sort of torch height control. Now, which ones to go with? That's a good question. In general, there's quite a few on the market. You know, I've dealt with the Proma for some time. It's an okay unit. I think it's well supported in the U.S. Through Eagle Plasma. I deal with Al over there. He's a great guy. But one thing I will say is that I found with certain clients, depending on what torch they're using, and again, torches are hitting the market, all different brands, they are not all produced to the same quality levels that they should be. You know, if you're using a $500 torch, be realistic. You know, when you're going to a Hypertherm that's $1,000, $2,000, $3,000, that's a huge, huge difference. So, you know, the grounding process on the units are different. You have to take all those variables into consideration. So be realistic. Typically, what I recommend is you guys contact me first about what torch you're using, and I will generally make a pretty good, I'd say about a 95% educated guess of which one you should go with, especially after I hear your budget and your applications. The reason I say that is because I like to recommend the best unit for the bang for your buck of what we're working with. Not, like I said, also for your budget and application. It's very difficult to say, hey, one unit goes with everyone. You know, a lot of guys say, why don't you just put the most expensive unit and just be done with it? A lot of guys can't afford that, you know, and a lot of guys may not need that. I'm being honest with you. You know, if you're not dealing with a lot of thin, you know, really, you know, 18 gauge and, you know, below, it's not always required. So it's something to really, really think about as far as what your budget is and what you want to get involved with. And that's why I say, once you guys contact me, let me know what your budget is, where you want to go with the system. Is this for business? Is it something that is required for precision parts? I've had guys need to cut out aviation parts. You know, you cannot, you know, play hit and miss when you're dealing with a government contractor. You want parts that are going to be dead nuts on. That's a totally different perspective. Their budget is always going to be above most novice business owners, where they're stepping in and saying, hey, I want to get involved. So keep that in mind. I mean, just keep that in mind. And once again, there's lots of opportunity on the market with torch height control. There's a lot of good units, and there's a lot of units that are, you know, all over the place as far as how support is done. I've seen a lot of different systems hitting the market lately that are in the budget range. The problem is when it comes to support, and that's the other factor, you know, you guys are going to have questions and you're going to have answers. That's another element that I'm very cautious with making recommendations to, because I want you guys to have this required support that you're going to need. Once you read these excerpts here explaining torch height control and see the variables involved and what you're dealing with, you'll figure out really quick having that support is imperative for your success, not just in hooking the unit up. A lot of guys think you just hook it up and go to work. It doesn't work that way. You know, you have to do trial and error, setting it up for your substrates, your chassis, and then things get done. That being said, and I'm just going to give you a quick example here. With the G540 system, which is 98% of the time what I recommend for plasma systems, mainly because the motor aspect fits the chassis perfectly. Speed aspect at 48 volts is going to be usually more than enough for even the largest chassis, even 8x10s. Usually you're going to be fine. And again, the budget aspect is right where it should be. This actual THC unit, this is just a demonstrator I wanted to do because I get asked about this system a lot. It's a Albert Price unit. It's called Price CNC's torch height control unit. Basically, it's an isolation module, and it's got a little digital input panel that regulates the torch height control through voltage. The thing I wanted to basically give you guys an aspect on, okay, is this is the hookup wiring diagram provided by Mr. Price. And in every system you guys go to purchase, this will be different based on what you're using it for. So for example, when you guys look at something like this, and I wanted to discuss this because, again, now we're getting into more my field where a lot of the questions that come in, I get guys that'll say, well, how is it that, I see all this diagram, but what do I really need to get this hooked up? Well, this is where it gets interesting. You can see here you've got 3 leads, okay, this green, this blue, and this brown, and this is just for example. And you can see here he broke it down of what you're actually dealing with. You got arc, OK, THC up, THC down. And then that's these 3 signals right here, and they're going into the input on the G540. Then you've got over here a 2 through 50 volt DC anti-drive signal wired into output, okay? And he's got this wired into output number 2 on the G540, which is actually terminal block 6 location. When I contacted Mr. Price, I wanted to ask him something because I was a little confused in the sense that from what I see here, and I see the general input setup up here, now this general input setup comes directly from Gecko themselves. Now, when it comes from Gecko themselves, this is just a sample setup, and you can see they have DC relays hooked up. Well, one of the things, just to make everybody aware of this, when you guys are dealing with a THC, you will require a relay to be installed in your system. So right there, you're going to increase the price of your system if you want to go that route. Now, 98% of the clients want to go that route. That is an option, okay? I do not always include that with the system because, once again, I don't know who I'm dealing with. I have some clients that want to do that themselves and save a bunch of money. There's a lot of wiring involved with a relay when you're doing it correctly. You have to shield the signal cables. You have to make sure it's mounted in the enclosure. You have to go through and wire everything in and make it symmetrical. I mean, when I'm selling it at a pro level and you're doing it yourself on what you accept yourself, that's one thing. When I'm selling it, I have to represent a repeatability factor of a professional. So therefore, you're going to be charged for that. So keep that in mind, and that's one of the questions that always comes up. But when you see this setup, as I was discussing here, this once again comes from Gecko's user's manual in the back. When you see this setup down here, and it says with THC, and you can see his diagram referencing the module, it doesn't reflect a relay in here, okay? But the relay is up here. Okay. Now I contacted Albert and I said to him, I said, look, I know the system's got to use a relay. And he said, yeah. He goes, refer to the general input setup, and you can see here that there's the relay. So again, to make this a complete wiring diagram, just so everybody's on the same page, where you could see terminal block input 5, which is output number 1 on the G540, you would require a wired in dry contact relay to close the contacts on your plasma torch, okay, to start the unit to cut. Okay, the other factor to look at, and a lot of guys look at this and it says down here CNC control enclosure. Okay, you're 99.9% of you are not going to directly connect the wires directly into the G540. The G540 requires an enclosure, a cooling system, all of this. That means that in this enclosure, you're going to have bulkhead connectors. You're going to have those connectors come through and actually wire to the G540 from those signal inputs, and then come over here and then break out into a cable that goes, once again, to the actual digital interface on this unit. And this is regardless of whatever you're using, whether it's this torch height, another torch height. His unit is actually very good. I've heard a lot of good things about it. I've had clients use it. They do like it. Again, it's at the lower price point. It does not include a floating head, which Albert does recommend in his user's manual. He does think that the floating head is an option that everybody should look at. Again, it's going to cost you money, so it's something to think about. But I have had clients use this system. It's an excellent system. He supports it excellent. Again, he's based in Ireland. the thing I want you guys to realize is understand that these wiring diagrams are general. Okay, he is building the wiring diagrams based on numerous systems using this. That being said, if I did not contact him and ask him about the relay input, you don't see it here with the G540. You see it up here. A lot of end users would have that question. A lot of my end users would have that question. So always ask, and that's the big thing. Make sure you understand what you're working with. You can also see here where it says stepper servo motor power supply. He's got an 8 to 35 volt DC powering the AVHC10, which is the digital interface. The thing to keep in mind is if you're running 48 volts for the Gecko, you're going to require a segregated power supply for this unit. So once again, price is going up. You need that in order to power the subsystem. So you can buy a 12 volt. I don't recommend, use the highest voltage you can buy economically. 12 volt really changes the EMI ratio. I recommend going with 12 volt if you can. Very cheap. Buy a wall power pack, plug it in, you're golden there. You don't have to go through, mounting a regular DC converted power supply from AC. But overall, these are things to actually, calculate in what it's going to cost to do a system. You can see you've got a different voltage here that's not supported by the power supply that's supplying power to the drive. Therefore, you'll require an additional power supply. Then when you come over here, all of these extra signals that you see, you're going to need ports for. So when guys ask me, why does the controller go up vastly in price? Now you understand why. There's a lot more wiring. There's a lot more shielding. There's variables of where I want to use ferrites, because I'm going to tell you right now, ferrites are going to act a lot better in certain aspects with the EMI penetration we deal with plasma systems. If you guys are designing your own system, I cannot emphasize it enough. Use all of your resources. Don't stick with just shielded cable if you can use ferrites, or if you can use a combination of ferrites and shielded cable. A lot of guys do that. That's the smartest way to give you the most bang for your buck. It's the simplest format in that you're using all your resources so you can pull them together to get the effect you're looking for. So again, seeing this and seeing how this unit is configured, it gives you an idea. When you talk about just connecting a relay, then you're factoring in all these additional connectors. So you'd have 1, 2, 3 inputs here going into 3 of the 4 inputs available on the G540. You can see here he has these 4 switches which are wired in series, and the reason they are is because he only has 1 input left on the G540 to use. Now, I don't recommend using physical switches. Once again, I did my soft limit and digital fixture video showing how you could bypass using them. That would save you some time and money. Another variable here that is never, ever, ever discussed. I've never seen it discussed, and I want to make sure you guys understand this. When you see that you have these black wires coming from each of these colored ones, they're grouped. If you watch Albert's video, you'll see that these wires are grouped together where you'll have a green and a black, the blue and the black, and the brown and the black. The black is going over to the negative terminal on the power supply, okay? And a lot of these diagrams, and I don't understand this, they always reflect, and even Gecko's reflects, all the switches going to 1 terminal. This is not correct, guys. You will not have, or you should not have, 5 or 6 leads going to a single terminal on a power supply. You do not do that. What you do is you use a terminal splitter coming from that input on the power supply to give you multiple inputs, allowing each switch to have its own negative input if that's what's connected, in which case it is. So we do that so that everything is neat. Once again, we're doing a star pattern. Everything is nice and neat and clean. Okay? You don't want to have 100 leads going into 1 terminal. So let's factor that in. And then you need to install, if I was building your system, I would have to install a terminal splitter in order to split out all these negative signals. And on top of that, I'm going to have 3 inputs here I'd have to wire. And then on top of that, I've got another input here, or excuse me, an output here I'd have to wire for your anti-dive signal, and another output for your relay, and of course all the wiring and mounting required for the hardware to support all these options. Now think in terms of money, and then you understand where I'm going with this. Okay, so when you guys are building your system, when you guys come up to the electronic aspect, always look at that. When guys are looking at, the complexity of these type of systems, like I said, you're dealing with a different animal. And this kind of breakdown visually, I think, really gives you guys an interpretation of what you're dealing with. In a typical router platform, you see they have all the switches wired in single inputs. In this perspective, you've got all your inputs taken generally from the AVHC. So therefore, they've only got that one input used for switches. So you can see how everything differentiates. If you guys are uncertain about something, first rule of thumb, ask. Ask the vendor. Do not go to, and this happens to me a lot, and I don't mind helping. However, if I don't know, the first thing I'm going to do is say, you need to go to the manufacturer. Okay, whoever sold you the component, whatever it may be, they need to represent what they're selling. You guys have to hold them accountable. Okay? It's no different than if I go and buy a Chevy car and then take it to Ford and try to have them support it. It's not going to happen. Okay? Most of the time, it's going to be, guys, need to go back to the dealer you purchase it from, and it's no different. Logic plays a huge role here. I don't mind helping if I can, but again, looking at diagrams like this, everybody needs to be on the same page. Everybody needs to understand what they're looking at, and again, the complexity in which they're building. Even if you're not building the system yourself, I have many guys say, Vin, I don't know the electronics, I just want you to build them. It doesn't mean I don't want you to understand what I'm doing, because at one point or another when you receive the system, you're going to have to service it. You're going to have to not be afraid to possibly go in there, oh, my relay I have to replace, or I want to add this feature, I want to do that, but I'll have to go inside. That's why I try to build the systems in a user-friendly format so that you guys aren't afraid. Every system I sell comes with a build overview video to give you guys an idea of what's going on. I hope most of you actually take that video, copy it to your hard drive, and save it, because it is good information to have. And then of course, if you do have questions, I'm always there, but you always have that perspective sitting there on your desktop or in the computer somewhere. So again, I hope you guys can see what we're discussing with these systems. Once again, the chassis on a plasma is never going to be a really costly investment. Those are usually very easy to fabricate. The carriages are readily available. You can buy them on eBay now. You can buy them from all sorts of vendors. Typically, they're roller bearings, and they're using square tubing and other types of chassis builds. But overall, be realistic with your investment as far as your torch and as far as your torch height control, and if you want to go that route. If you do want to go that route, I think now you can see, even on a mild system, like I said, this unit's about, I think it's 300, 340, something like that. And again, great system for mid-level. If you're going to go with the floating head, you'll have to purchase that. If you're going to go with any type of add-ons, again, this is exactly what this system comes with. You will have to purchase the relay. If you're going to build it yourself, you'll need the relay. You'll need the additional power supply. And again, I'm just speaking for the G540. If you're looking at a different system, if you're doing individual drives, again, the hookups then change totally. So you could see, once again, the stress and pressure put on the manufacturers who are manufacturing the torch height control, why it's so difficult. You'll have to do 6 or 7 different diagrams to reflect each individual component that the unit will be hooked up to potentially. So keep that in mind. Really, really think about what's going on. That's why I say get to know your vendor. If you're looking at purchasing this system, contact Albert. I'm sure he'll be glad to help you. And again, get you put on the right track. If we're going down with the system, you want to make sure you understand exactly what you're getting involved with. Understand all of the requirements of the unit. This way, when you request a quote, you don't get sticker shock by, wow, why is that so expensive? And then you see this and you'll understand it. That's the big thing. And again, with the torch height control, I can't emphasize it, guys. Read. Again, start with Hypertherm. You could probably even call them if you have a Hypertherm torch. I know you can call them and talk to them. You can see this was posted 2 years ago, so this is really, really recent information compared to what's online. And they cover basically everything. Elements of the THC, gives you a whole idea of what's going on. They usually discuss the floating head design. A lot of them will deal with fully automated Z-axis THC. There's a lot of different versions, so just keep that in mind. You'll have ohmic sensors and lots of different versions that are out there. Research that. If you need more help, let me know. I'll do my best to help you, but hopefully this video has explained the general guidelines. Like I said, when it comes to the controller aspect, that's never usually the difficult part with a plasma. A 4-axis general G540 system is going to give you perfect results. Again, we deal with the shielded cables, of course. I don't sell anything without them. you're generally going to be just fine. And then you'll decide how you want to control the system, whether we go USB with a UC100, whether we go Ethernet with an Ethernet smooth stepper, or if we go with a DB25 if you want to go retro. It's totally up to you. The big thing here is that you guys understand what you're dealing with and then move from there as far as budget. Now, to cover the final part of this video is the budget. What you'll expect to pay typically for a plasma system. And when I say a plasma system, if you're building the table and you already have the torch, usually for the plasma system itself, it can be anywhere from $1,300 all the way up to $2,500. And again, not including your torch height control. Okay, depending upon what torch height control you're going with, again, that's why I recommend you guys contact me first. This way I can build a controller to the torch height control you're using. I deal with that all the time. Again, none of my systems are cookie cutter. Every system is individual, right down to the graphics supporting the system, because what one guy requires, another guy may not. What one guy can afford, another guy may not. So keep that in mind. And once again, I hope this video has been helpful. If you guys have questions, I know you're going to have many. Don't be afraid to ask. Once again, first, with a plasma system, go down the line with vendor support. If you're buying a Hypertherm torch, ask Hypertherm first. If you're buying a Kindle THC and you say, Vin, what do you think of a Kindle? And I send you there, contact Kindle about that. They're going to be the masters of that. If you contact Albert Price, he's going to be the masters of his THC. If you contact me about the actual controller, I'm going to be the master of that, and I can then guide you with that. That is the best way to do it. Document everything as best you can, and this way you'll have a really good understanding of what you're getting involved with and know that your investment is sound. That's the main thing, is that your investment is always sound and everybody is getting what they want. And again, you can progress with your business or your hobby, whatever it may be. So again, I hope this video has been helpful. I'm going to put links for, once again, this blog post and also the transmission breakdown from ShopSaver, once again, so you guys can review it yourselves. And again, guys, I mean, most of you have really been enjoying a lot of the videos. If you guys want to see a video based on any of this stuff in specific detail, let me know. I'll do my best to accommodate you. If it's a video that's already been done, because I do get some video requests, if it's stuff that's blatantly been done before, I try to make the videos that I do things that I haven't seen done, only to keep my time, acclimated in the right spot, so to speak. So just keep that in mind. But if you guys have any questions, once again, you can contact me at storm2313@gmail.com. That's my direct email. You can also contact me through my eDealers direct store on eBay. I'll put both their links down below. Once again, to all my subscribers, I love you guys. Thank you so much. I will keep the videos coming. And again, if you guys need anything, let me know. Thank you again. Take care.